I've got a bearing sat here, it's just started. I've got the chuck loose, but just on the inner race of the bearing. In fact, I could probably go a little bit tighter. Let's have a look. It's loose, so it should slide through the jaws. Tailstock locked off, and yeah, that's winding in. So another mistake made. I've just pushed the first bearing on, as you just saw, wound it in with the tailstock, went in, no problems at all. A little bit snug, and it did not pick up, but you could see a bit of shininess on here, so I've just given it a slightest polish. But anyway, I know that shoulder where the bearing goes on there is 24, and I was thinking 2mm spacer, 10mm bearing, 2mm spacer, 10mm bearing, should come to within about 2mm of there, and I was thinking, well, that's a long way back. Turns out my bearings aren't 10mm, they're 8mm. Not a worry, I'll just make myself, instead of the 2mm spacer, which I had earlier on, that goes between two bearings, I'll put a, well, it'll be 2/4, it'll be a 6mm spacer now. So yeah, just got to make a 6mm spacer, and I'll carry on assembling. So I got a piece of brass up, I've just faced it, skimmed the OD to something like what I want. Oh, a little bit fast. I'll just centre drill the end. Really nicely. And then we'll have a, I think a 7mm drill, something like that. Just rough it out with that. That should do me. I want 2, 4, about 6mm I need. And you just pop that drill in there to about 10mm deep, something like that. That should do me. Oh yeah, more than enough. And then 10.5 drill, and the phone's ringing. So I just put 10.5mm drill. Put that through. Got a little bit more than enough. Yep. Over brief, yes. I've probably got about 15mm deep in there. I only needed to be about 8. Anyway, that's a 10mm, so we'll part it off next. Probably just take the edge off there and break the front edge or the leading edge of the hole. Start the parting off, break the back edge, and then part it off. Just put a little chamfer on that leading edge. Take the edge in that bore there with a half round needle file. I've set the parting tool 6mm back from the front edge, so I've just parted off. It's actually a piece of bronze. Break that back edge. Speed the bugger up a bit. There we go, parted off. So I've parted it off. Just need a little deburr on that back face. And the front for that as well. I'll check the thickness, and that's my 6mm spacer. So I've got this large part of the shaft against the jaws on the front of my chuck, and again I'll just wind that in. I've got a bit of oil on the shaft. 6mm spacer fitted lovely, and that's the second bearing fitted. So there we are. That's the two bearings with a spacer between them fitted on the shaft. And they still feel lovely. So exactly the same again. And we're only talking hundredths of interference fit here. Just using the tailstock to keep it nice and square. And wind the two bearings in. And that's it, they come to a stop. So that's the front bearings and the shaft fitted. Again, I fitted it all up the other way. Let me see if I can give you a better shot. All up the other way. I'm just not gripped on those threads, it's just those threads are fitting between the jaws there. I lined it all up with the centre, put the bearing on over the 5mm. Right, and let's just wind that into the housing and come to a stop. A little bit more. In she goes. And a touch more, I think. And that's the rear bearing fitted. Wouldn't it be nice to have a press? So what I'm looking to do next is make a little adapter, piece of steel that screws down on that M5 and will close down against the inner race of that bearing at the back, perhaps with a bit of clearance so it's a little bit longer in the threads, to stop this shaft being able to slide forward. And then on the end of the adapter I will have a piece of 3.2 diameter which will slide into the collet on here, 1/8 collet, and I can tighten up with a nut. Then I think a piece of 20mm tube of some description, or a piece of aluminium with 20mm up the bore, that I can slide back over this, and then once I've done up the union, slide it forward, clamp it with a grub screw on there and a grub screw on the top of here to lock the two together, so that the old unit with rubbish no bearings in it, so to speak, will drive my new spindle which has got the decent bearings. Okay, so that's the next plan. Piece of tube and an adapter. So making up a little adapter to go on the M5 thread on the end, I'm going to need to, I've just faced it, given a little piece of silver steel here, giving it a skim, centre drill the end and drill and tap M5. Now it needs to be long enough of M5 for the back shoulder here to come hard against the inner race of this bearing. I may skim a little recess in the end just to avoid the outer race. I think it misses it anywhere at that diameter, but a little recess on the end, we'll show you that. And drill and tap it out, and I may have to counterbore it like 5.5 over the first few mil just to avoid that solid M5 section there. So drill and tap the end. So start off as usual, centre drill the end. Put a little bit of my cutting compound on it. Oops, bang the camera. Just be very gentle, it's a small centre drill this. Okay, that'll do me. So the length I'm looking for is a thread depth of, it's going to have to be at least 12mm. I'll probably drill about 15mm and then use it right down to a plug tap to get the threads as deep as I can. So again, a little bit of oil, 15mm. Okay, 1, 2, 3, 4, 5, mil, 10, 11, 12, 13, 14. It's just starting to clog a bit. Oh, 1 more mil. That's 15 mil. So, get rid of the 4.2. I'm going to go up with a 5.2 now. And the 5.2 is so that the last bit, as it goes on there, will avoid that 5 plane diameter. And I probably need to take this in. I think I could safely go in 5 mil. So 5.2 in to 5 mil deep. Just touch. 1, 2, 3, 4, 5. Lovely job. I think we'll have a little chamfer on the front of there, and I'll tap it in series of M5 taps, which I have got. I've got M5 standard taps. Drill it out and then put a bottoming tap in, just to make sure our threads go as far down as I can possibly go, or at least the distance that's needed to cover that area. So a little chamfer's needed on the front edge. I'll just use a centre drill for that. Does help when you do the tailstock up. Yeah, that's a neat little chamfer, that'll do me. So I've been in with the first tap, just going to go in now with a plug. Haven't reached the bottom of the thread yet. Not using my winding handle, just my hand friction, and the tap started to rotate. That's right into the bottom. Just do it once more. Yep. That's right into the bottom. I've removed my lathe tool from here so there's no sharp objects. Always worth doing if you can just pop the tool out the way, so that when you've got your hands in and you're doing something like this operation, you've got nothing sharp you're going to catch yourself on. Because one slip of the hand, a lathe tool will take a nasty cut out of you. No problem at all. There we go. So that's that, tapped. So I've just machined a little 1 mil step on the front of there, taking it down to the diameter of the inner race of the 6 mil bearing, and then machined the rest back by 1 mil, so that I know when I screw this on, that centre area there is going to clamp on the inner race of the bearing, which will stop the shaft coming out. So I'll just put a 45 on the top of here, and we'll chop it off and turn it round. So I flipped the little adapter round in the lathe, and I've turned it down to 3.2 over 20 mil, and then leading back in, I put like a 45 degrees from the bottom back up to try and give it a bit of strength in the base of that, rather than have a square corner, something that could be easily snapped off. I think that'll give it a bit more strength, and there is a little radius right in the bottom as well. And the 3.2 collet fits on and comes just flush with the end. So I know I can attach this to my flexible drive, and I know by screwing that on the back of my tool I can attach this to the back of my head unit. So there's the adapter. So the next thing I'm going to need is a collar, and that's a piece of silver steel, that one, so it's fairly tough. So as long as I'm not daft with it, that very small diameter sticking out of there should be okay. So next thing to do is make the sleeve. I've got to a point where I can try this out. So let's see where we are. Plan A was to fit this holder through the 20 mil bore in this tool post adapter, we'll call it. We found that the bearings in this were absolutely useless, so we went with plan B, and plan B was make a spindle with some bearings. Okay. Plan C, after having cocked up the thread on the end of the spindle, make a nut, did that. Plan D, I had to make a replacement spacer because the one I made was too thin. It was a 2mm one instead of a 6 anyway. Did that. Plan E was make an adapter for this end so that I could fit this flexible coupling straight onto the adapter. It's not the best, but it's moved me on to plan F. Now then, the little die grinder I got, even if I have the flexi in a straight line, it's 135 watt. I ran it for approximately a minute and it is really, really hot. I don't think it's man enough for the job I want. I could see it coming. I didn't think it was going to be after having tried the initial holder. But whether it's taking too much effort to drive the flexi, I've tried it even in a straight line and it didn't help. And obviously the extra load of bearings. Now, I mean, there is no load. I mean, I'm driving the whole lot here. There's no load on these bearings. It's very free running. If I hold it by the spindle, you know, it'll spin on its own. So it's not tight. I think I'm going to need, long term, a bigger one of these. But what I am going to try is maybe connecting this directly on the end and do away with the flexi. So that's going to be plan F.